that is with backend data via OData service, table element with backend data by using OData service. That's the main topic. After that, we'll discuss icon tab bar. And in the next session, once again, we are going to discuss table with formatter functions. After that, I'll clarify doubts in the next session. So first of all, the table class is available in two libraries here. For table element, SAP has provided table class in two libraries. One is like table class from SAP.m library. And then there is a table class from SAP UI table library. So there are two different libraries which contains table class. SAP.m library, this is suitable for SAP Fiori apps. That means supports all devices. It is suitable for SAP Fiori apps and it supports all devices here. But in case of SAP UI table library, SAP UI table library, this is suitable for regular SAP ui5 apps, that means old applications, and this supports only desktops mainly. Desktops, or I can say laptops here. But in case of SAP.m library, it is going to support all devices. That means desktops, laptops, tablets, and mobile screens. So table class from SAP.m library, this is recommended because it is suitable for Fiori apps. In the future also, SAP recommends you to go for Fiori apps. Why? Because it supports all devices here, desktops, laptops, tablets, and mobile. But in old applications, there is a table class which we used to use earlier in older applications in ui5 development from SAP UI table library. But it supports only desktops and laptop screens here, not tablets and mobile screens. So here, table element is considered as complex element because table element contains several columns and columns contains different other elements. That means because in table, we can use other elements as internal elements. In table columns, table element is considered as complex element. Why? Because inside a table, we can use other elements as internal elements as part of table columns. So table contains table columns. Each table column can have other type of elements. It can be text element, link element, image, slider, progress, indicator, rating indicator, checkbox, switch, etc. We can use other elements as internal elements in table columns of a table. That's the reason why it is simply called as complex element here. So here, there can be a table. Table supports internal element. and internal signalement contains property. So table can have a table column, and it can have an internal signalement as text signalement, which contains text property. Similarly, table can have table column, and you can use input as internal signalement with value property. Table can have table column with the text area. Text area contains value property. Table with table column can use checkbox. And checkbox can have selected property here. Similarly, table can have table column with switch screen element as internal screen element. And switch can have state property. Then table with table column can use rating indicator. Rating indicator contains value property. Table with table column can use progress indicator. Progress indicator contains percent value property. Similarly, table can use table column with image. Image contains SRC property. Table column supports button as internal screen element with the text property. Table column in a table supports link screen element. Link contains text and href property. Similarly, table with table column can use date picker. Date picker contains value property. And table column can use time picker with value property. Table with table column can also use slider, and slider contains value property. So the point here is table contains table column. Inside each table column, we can use different screen elements as internal screen elements with its own properties. Inside table, we can use other screen elements as internal screen elements in table columns in this manner. And it supports all types of OData services here. Table screen element is common for all types of OData services. All types of backend OData services. It can be OData ABAP service or OData CDS service, or it can be OData external service. It doesn't matter. Table behavior, table screen element remains same. Coding wise, syntax wise, everything is same, irrespective of the backend service. Okay, let me give one simple diagram before writing the code. So when we construct a table, in Fiori applications, when we construct a table, we try to make use of a table with items as aggregation property. Items as aggregation property. For that, we are going to maintain configuration with entity set of OData service. Table contains items as aggregation property. For that, we can configure entity set of OData service. So this entity set of OData service internally executes get entity set method of OData service in the backend. When we do this, table items as aggregation property by configuring entity set, it executes get entity set method of backend OData service. And not only that, entity set will collect data from backend and display data in front end. The purpose of entity set is to collect data from backend and display data in front end application. So these things will happen when you configure entity set with aggregation property. So these things will internally happen when you configure entity set of OData service with items aggregation property of table. Okay, let me just put it like this. Now, let me make you understand how exactly table can be designed. So in a table, we can have table with column. First, you need to, while writing the code, first you need to think about column. For example, column 1, column 2, etc. So you can have n number of columns here. Column 1, column 2. So we can create n number of columns here. While constructing a table, first you need to focus on column option here. Something like this. So this will help you while constructing a table, especially when you're making a table complex, then this procedure is simple and important. So for table, items is aggregation property, configure entity set. After that, construct table with columns here. Add one more. So you can add n number of columns inside a table. But for each column, there should be a separate label. For each column, there should be a column with a label. Example, column label. So for each column, let us add one column label here. And the second thing that you need to consider while constructing table. So for each column, there should be column label. While constructing the table, so this approach will help you in easily write the code. Then you need to think about the screen element. For each column, there should be a screen element. For each column, there should be something like a screen element here. So you can see we can add a text view, for example, as a screen element. We can add text view as a screen element. Or we can add text field, that means input field as a screen element. And we can add something like text area as part of table column as an internal screen element. We can use input with password field. Input with password field as an internal screen element in a table column. We can use image as an internal screen element in table column. Progress indicator. We can use that as internal screen element. in table column. We can use slider as entrance signalement in table column. We can use rating indicator as entrance signalement in table column. Then we can use link. We can use date picker. We can use button. We can use drop down box, that is select signalement. So inside table columns, in each table column, we can use one entrance signalement. Text view or input, text area, password field, image field, rating indicator, progress indicator, slider, link, date picker, button, select, etc. So under each column, while writing the code, you have to decide which entrance signalement you want to use. You need not use every time different signalements. You can use same signalement in different columns. You can use different signalements in different columns. Either way, you can use it. You can use same signalement in all the columns. You can use different signalements in different columns. It all depends on the requirement. You can use it either way. Today we'll use, in every column today we will be using text view signalement. For all the columns in today's session, I'll try to use text view signalement. In the next session, we'll try to add different signalements in different columns by using formatter functions. Okay, whatever it may be, the entrance signalement has to be decided here. Whether it is same signalement or different signalement, but the entrance signalement must be used in table column. After that, you need to make use of the property for that entrance signalement. For text view, you have to use text property. For input field, we have to use value property. For text area, value property. Input with password, there should be value property. Image with SRC property. Progress indicator, percent value property. Slider with value property. Rating indicator, also with value property. Link, we can use text or href property. Date picker contains value property. Button, text property. And select signalement, you can use text property for items. So depending upon the entrance signalement, the property is decided here. While writing the code, depending upon the internal signalement in a table column, the property of that internal signalement is decided here. Now, as a developer, after adding internal signalement, you need to maintain data binding with OData field. You have to maintain data binding with backend OData field. For example, OData field 1, field 2, etc. You can maintain data binding relation with OData field here. So for each column, internal signalement property, you have to establish data binding relation with OData field. So this is how you can fetch data from backend to the front-end table signalement. You have to establish data binding relation with OData field. Then only you can expect data from backend and you can display data in the front end for those respective fields. So here, what exactly we are trying to do is we're constructing a table here. Okay, let me complete like this. creating a table with columns. In each column, there should be a column label. And for each column, there should be an internal screen element with its property. For each column, there should be an internal screen element with its property. And then for each column internal screen element property, you need to establish data binding relation with OData field here. You have to establish data binding relation with OData field. So because of that data binding, you can expect collection of records here. You can expect collection of records in this table. And if you want, you can attach formatter functions. That's a next session. Don't worry. If required, we can apply conditions, validations, all those things are possible through formatter functions. So this is how you can expect collection of records here. The different columns, you can have different screen elements or same screen elements, but ultimately with this approach, you can expect collection of records coming from backend. It can be a number of records in this case. So while constructing table, just follow this approach here. Okay, let me complete this. Okay, so that means while writing the code, first you need to use a table with items as aggregation property and maintain configuration with entity set. In the backend, get entity set method is executed with select query. When select query is executed, entity set will collect data from backend and display data in the front end. On top of that, while writing the code, so first you need to decide the column. After that, you need to provide column with column label. Column with column label. And then you need to decide the internal screen element here for that column. Internal screen element for the table column. And then for internal screen element, you need to decide the property of internal screen element. That should be used here. For property of internal screen element, you need to establish data binding relation with OData field here. You need to maintain data binding relationship with OData field here for internal screen element property. So here data binding will be established between internal screen element property and OData field. So that we are calling it as data binding. It's nothing but relationship between internal screen element property and OData field. So ultimately, you can expect collection of records in this table screen element. And the data can come from backend system via OData service. First, we'll fetch all records. At some point of time in the future topics, we'll be discussing how to filter the data based on filter input, you can display the respective output. So whatever we are trying to do today is not the final table. We'll be doing different operations in coming days. Let me just save this. Table screen element. Now, most of these options we are going to use tomorrow. For today, in each column, we are going to use text screen element with text property as internal screen element for all the columns. In the next session, we'll go with another requirement so that we can fix all these internal screen elements in different columns. Now, for today's session, as I told you, we are trying to use OData service. The same service, we are going to use it for fetching data to table. So OData service name is the same service we have used earlier. Table also will use the same service. Z8am CRUD OData project SRV. And OData entity set, we have used EMP set. For table also we'll use EMP set. We used OData fields like user ID, first name, last name. These are the fields that are part of OData service. In today's session, we'll try to add all these OData fields in data binding for table screen element. And don't forget, entity set name and OData fields are case sensitive here. Entity set names and OData fields are case sensitive. Use it as it is. This is how it is registered in the backend system. The same options you have to use it in the front end. It's case sensitive. Now let me give some description for table. So table screen element contains items as aggregation property. Don't forget that. For items aggregation property, we just configure entity set of OData service. Why we configure entity set? This is to collect data from backend and display data in front end. For that, we have to configure entity set. And not only that, table can use table columns with any internal screen element. Table can use table columns with any internal screen element based on internal screen element. Based on internal screen element, the property is decided here. So for internal screen element property, we maintain data binding relationship with backend OData fields. Depending upon internal screen element, for internal screen element property, we maintain data binding relationship with OData field. For internal screen element property, we have to establish data binding relation with OData field. So while writing the code, just remember these basics here. Now let me write step-by-step procedure. Step 1. Step 1, open object view XML file, and you can go inside content section. Step 2, implement below code or table. We'll try to write the code. We'll understand some basics. In the next session, we'll try to improvise that table. We can go for doubt session after that. So here, there is a table. For table also, we have to use sap.m library in Fiori apps. It's recommended. Not only table class, column class, these are all part of sap.m library. sap.m is a library which internally contains table class as well as column class. Okay, that you can understand here while writing the code. So let me go to this. There is content section. Within that content section, we are writing all these lines. The end of content section. So within this content block, in the last session, we have created list, panel, etc. Similarly, we'll try to create table here. Use begin tag, end tag. Use begin tag, end tag here. And table contains items as aggregation property. So we are going to configure entity set here. And you can use some width. For example, 900 pixel. Now table also contains other aggregation properties like columns. Columns is another aggregation property. So columns is another aggregation property. And table contains items which will fetch data from backend. And not only that, we have to use internal screen element for that. So that's the reason why you have to use items here again. Items will fetch data from backend. On top of that, for these items, there should be some internal screen element. So you have to use items again as aggregation property here. So two aggregation properties we are using within this table block. Columns is one aggregation property. Items is another aggregation property. So for columns, you need to use column list item here. Sorry, for columns, you have to use column with a label. For column, use column with a label. So this is column begin tag, end tag. And here in items, you have to use column list item. Under items, you have to use column list item, use begin tag, end tag. Items is aggregation property which internally supports column list item. And here columns is aggregation property which supports column as one of the option here. Use begin tag, end tag. Here also use begin tag, end tag. And within this column, you can use something like label. For label, you can directly use a single tag with end block, and you can use column with label, text. For example, user ID. In column list item, you have to use cells internally. So cells is again an aggregation property for column list item. So column list item internally contains once again cells as aggregation property. So inside cells, you have to use internal screen element here. So approach you have to follow with its property and maintain data binding with OData field here. for so and so column label, this screen element will be associated with that according to the sequence. First column with first internal screen element. So here I've decided to use text screen element which contains text property. So ultimately you have to maintain data binding with OData field. So here, similarly, I can add one more column here. Column with label. And label contains text. Example, let me use first name. So there's a column, label. Label contains text. And you can provide some text value. For this second column, there should be an internal screen element. So here I can use text screen element again, text property, maintain data binding with OData field here. So first column label will automatically associate with first text screen element. Second column label is associated with second text screen element here. It will take that sequence as per your coding sequence. Output sequence will be technically equal to the coding sequence here. First column label will be with first text screen element, second column label with second text screen element here. And then you can use, for example, let me use column, it should have its label. And you can close that label directly. Let me provide last name here. If you want, you can add design property here also. Let's make design also. For design, let us use bold. For each label, let me add this as well. So for third column label, we are trying to use another text screen element, but here you have to establish data binding with OData field. Backend OData field. Can be field 1, field 2, field 3. So this is a basic technique you need to follow for constructing a table. Okay, so first let me take this syntax as an outline, skeleton syntax. Let me just make this as a skeleton syntax. And if you want, you can use some properties here like growing, which we have used on list also. These are normal properties. Growing, you can make it true. Growing threshold, example 15. So this is like you're adding paginator, which I've already explained on list. The same properties are applicable for table as well. Growing and growing threshold. These properties are common for table and list. So this is skeleton code. For this, what we are trying to do is here, this is a table. We are trying to use this as a complex screen element. You can call it as a main screen element, whatever. For that, we are using items as one of the aggregation property because it has to get data from backend. Aggregation property should be used here. And you need to maintain configuration with entity set of OData service. Why we have to configure? This is just to collect data from backend, display data in front end. front-end app or front-end, whatever. Collect data from backend, display data in front-end. For that, we are configuring entity set. And then here we are trying to use, okay, this is a table format. The table contains two sections here. One is column section. This is column section. And then there is item section. In column section, you can add column with label. In column section, you can add column with labels. In item section, you have to use column list item with cells. In column list item, you have to use column list item with cells. Then only you can add internal screen element and you can maintain data binding. So technically here, this is the column label. For this screen element will be taken as a first internal screen element for first column label. Then there is a second column label. And then there is a second internal screen element for that. Then there is a third column label here. There is third column label. And here we are having third internal screen element. So this sequence is followed when you run the output. When you run the table output, this first label for first OData field, second label for second OData field, third label for third OData field. And it is applicable for column 1, column 2, column 3. First column, text screen element, second column, text screen element, third column, text screen element. So that is the sequence by default it will take. So that means here what we are trying to do is for each column we are providing a label. Let me write that here. For each column we are providing a label, and for each column we are using an internal screen element. And we are establishing data binding. So let me write some description. Each column, we provide label. For each column, we have to provide label. And not only that, for each column, we need to provide internal screen elements. We have to provide internal screen element. For each column, there is a label. For each column, there is an internal screen element. For internal screen element, what we need to do? For internal screen element, property. For internal screen element property, we have to maintain data binding relationship with OData field. Very simple. Each column with a label. Each column also contains internal screen element. For internal screen element property, just establish data binding relation with OData field. They're expecting data from backend system. This is the approach you need to follow. Okay, so let me add some more columns and then we'll experience this table output. The table skeleton code. In the next session, we'll add different screen elements with different properties and we'll apply conditions through formatter functions. So today's output will be basic table output. Okay, so let me add some more columns here with labels. This is for email ID, country, salary, and let me add one more, phone number. So for each of these columns, let us add internal screen element, property, and data binding with OData field. So let me add internal screen element, same text screen element, text property, data binding with OData field. So this is fourth OData field, 5, 6, 7, something like that. Now here, what you need to do. For items aggregation property, configure entity set. So in our case, entity set is EMP set and it is case sensitive. So try to use it here. EMP set is our entity set. In real time, it can be XYZ in that service. It can be XYZ SET. It can be ABC SET. That will be entity set basically. In real time, it can be anything. In our case, we are having EMP set. Now we need to establish data binding relation with OData field by using flower brackets here. You have to use flower brackets in general. Within flower brackets, you need to mention OData field name. Use double quotes, flower brackets. Within flower brackets, you need to establish data binding relation with OData fields. So here, these are the OData fields. Let me use all these things for table. And these OData field names are case sensitive. When you're fetching the data or when you're inserting data, updating data, deleting data, the field names are case sensitive. Whatever is available in OData service level, the same names with same case sensitive rule, you have to use it in the front end as well. Not only while fetching the data, not only for table, we are going to use these fields for inserting data, deleting data, updating data. At that level also, we'll be using the same approach. The field names are case sensitive here. Okay, so let me add those fields. For example, user ID, first name, last name, email ID, country, salary, and then phone number. Okay, so you can save it here. Now let me run this. So here there is carousel, there is a form, there is a list, and now there is a table. Below the list, there is a table, and here we are able to get the data for these things. If you want, you can increase this bit for these columns. Email ID, let me increase the column, or let us use some option like fixed layout as false. Use fixed layout as one property, you can make it false. Then it will be automatically adjusted mainly. Let us run this. Okay, now you can see it is now much more meaningful compared to previous output. So there is no overlapping. User ID, first name, email ID, last name, country, salary, phone. So everything is displayed, and table contains more option because of growing property here. So this is a basic table output, and this output is basically the records are coming from backend system via OData service here. This is not static data. This is data coming from backend system via OData service. Okay, let me just take this screenshot here. It's like table output. Let me write it. This is just a basic table output. Right now, this is working. So what you can do is just open object-view.xml file. Go to content section block. Within that block, just implement below code for table. So the code is this one. That is how it looks like. Now here, if you want to apply conditions, validations, then on internal screen element, we have to attach formatter functions. On internal screen element, we can attach formatter functions. That we'll discuss later, but before that, here you can see, if you closely observe the screen, we are able to add too many screen elements here: carousel, panels, forms, and then there is a list and there is a table. If you want, you can add table inside a panel also. But instead of using panel, I want to use a different screen elements. For example, I want to use like a tab strip. I want to add different tabs in a tab strip. And in each tab, I want to add some different screen elements. So in Fiori applications, we have to use icon tab bar. That is similar to tab strip here. Icon tab bar, that's one of the screen element. This is similar to tab strip. Icon tab bar is similar to tab strip, and this is very commonly used. Icon tab bar is collection of icon tab filters. Icon tab bar is collection of icon tab filters, which means a collection of tabs. Each icon tab bar filter, each icon tab filter contains content area. Inside each icon tab filter, it contains content area. And each content area, we can display one or many screen elements. Icon tab bar is similar to tab strip. Icon tab bar is collection of icon tab filters, and each icon tab filter contains separate content area. Each content area, we can display one or many screen elements. You can implement below code. Okay, first let me give one basic idea here, what exactly we are going to do in the future and in today's session. So here you can see icon tab bar. It's one of the screen element which is similar to a tab strip. Now this icon tab bar can have collection of icon tab filters. Icon tab filter 1, filter 2, you can have a number of icon tab filters. We can have collection of icon tab filters like this. So inside each icon tab filter, we can place content area. Each icon tab filter contains a separate content section. container with a separate content section. So that means this is how it looks like. Icon tab filter with a separate content area. Select one main container here. So it contains collection of icon tab filters. Inside icon tab bar content container, you can have all these things. So in each icon tab filter, there is a separate content area. Now what we can do is we can place all these icon tab filters in icon tab bar here, because icon tab bar is collection of icon tab filters. In each icon tab filter, there is a content area. Under content area, we can place one or many screen elements. For example, I can place a simple form here. We can place list screen element here. We can place table screen element. And in the future, we are going to add something like microchart. And we are going to add charts. We can also place fragment or a nested view. All those things are possible. So here, in each icon tab filter content area, we can place different screen elements or one or many screen elements, something like that. As an example, we can place form here, list here, table, microchart, charts, fragment, nested view, file uploader, downloader, etc. We are going to add many more things. So this is something like a tab strip which contains tabs. Each tab contains one or many screen elements. There is no tab strip class. Instead of tab strip class, you have to use icon tab bar class. Instead of tab, you have to use icon tab filter. That's nothing but tab. Okay, so let me save this. Icon tab bar with collection of icon tab filters. These filters are not to filter the data. That is a class name for creating a tab. Don't misunderstand this. Icon tab filter is not to filter the output data. It's not for that. It is to create icon tab. Tab means it's like a separate content area it will generate. Okay, this icon tab bar is collection of icon tab filters. Now, let me give the skeleton code first. After that, we'll try to improvise this output. We are having too many screen elements now in the same screen. So what we can do is we can create one icon tab bar here. Let me add that. You can use begin tag, end tag, icon tab bar. So use begin tag, end tag here. Icon tab bar internally contains aggregation property, items. Items as one of the aggregation property. And items supports icon tab filter. Item supports icon tab filter with separate content area here. Items aggregation property internal supports icon tab filter with separate content area. And you can have n number of icon tab filters here. Icon tab filter 1, filter 2, filter 3. You can have n number of icon tab filters. Something like this. So here items is aggregation property of icon tab bar, which contains collection of icon tab filters here. And each icon tab filter has a separate content area. Okay, so here, okay, let me put it like this.
Muted.
And then there is another property. We can use icon color. Icon color. So here we can use different colors here. Critical, default, negative, neutral, positive. So it supports constants here. Each constant supports one separate color. So for this, let me use positive here. I think green color icon. And what should be the icon that you can provide here? You can use custom icon or you can use standard icon. First, let me use standard icon. For standard icon, you have to use SAP-icon : // for the syntax for using standard icon.
Muted.
Icon, for example, standard icon, there is icon name with something like doctor. Similarly, for each icon tab filter, you can use text. This is for list. And let me use for here, let me use icon color. For example, negative. I think it's red color. And I want to use icon. Here, I want to use standard icon. So SAP-icon : // then you can use some icon name, for example, world. That's one of the icon name. And the same thing you can apply for icon tab filter. I want to use table here. I want to use color as, for example, neutral. I want to use icon, for example, process is one of the icon. For each icon tab filter, you can provide text, icon color, and icon. For each icon tab filter, there can be text, icon color, and icon. And each icon tab filter contains a separate content area here. So this is skeleton code. You can use it and you can place whichever screen elements you want inside content area. Let me just take the screenshot as this. Let me run this without any screen element. icon tab filter content area is blank here. No screen element is used. First, let me run this. Okay, now you can see at the bottom. At the bottom, you can see below the table, there is icon tab bar with 3 icon tabs. That means one icon tab bar contains 3 icon tab filters here. You can notice that. Okay, let me use neutral. So at the bottom of a table, you can see there is form, list, it's blank, table, it's blank. So this is like icon tab bar with 3 icon tab filters at this point of time. And each icon tab filter contains a separate content area. Content area is blank now. But I want to add form in first content area. I want to add list in second content area. And I want to add table in third content area. But as of now, this is a skeleton code here. The skeleton code that you should remember. On top of this, you can add whatever you want. In content areas. So here, this is the overall icon tab bar. And icon tab bar contains 3 icon tab filters here in this case. We can increase, we are going to do it in the coming days. So it contains 3 icon tab filters here. And here, each icon tab filter contains a separate content area. Don't forget that. So inside this content area, we can place our screen elements, collection of screen elements, or one screen element or many screen elements. It's up to you. It doesn't matter. You can place your one or many screen elements. For example, I want to add simple form code here. Similarly, here I want to place some screen elements. You can place one or many screen elements. For example, I want to add list code here. Then here also you can place your collection of screen elements. It can be one or many screen elements. For example, I want to add table code here. So this is how you can construct icon tab bar, which is very commonly used in almost in all Fiori applications, or at least 90% of the Fiori apps, you will find this icon tab bar with icon tab filters. So almost all the Fiori apps will have this screen element because it will generate tabs with each tab contains a separate screen element. That's how we can generate the output screen. That's the reason why it is commonly used. Generate separate sections. In each section, you can place screen elements here. Okay, so this is a skeleton code. On top of this, you can add whatever screen element you want here. You can make changes. It's up to you. Let me save this. Icon tab bar, skeleton code. In that skeleton code, you can place your screen elements. Here, in first icon tab filter, I want to place form. In second icon tab filter, I want to place list. Third icon tab filter, I want to place table. So first, let me place table here. Let me take this entire table code. You can cut this table code and paste it here. Within icon tab filter, third content area is a table now. Now in second icon tab filter, content area, I want to place list screen element. You can cut this code, list code. If you want, you can remove this panel. Panel is not required now. Place that list code here. There is a list inside second icon tab filter content area. Okay, first let me copy these lines as a skeleton code. After that, we can do this. Let me copy the skeleton code. Cross check once again. Let me check whether it's working or not. Okay, so this is skeleton code. It is working. By default, it displays empty screen elements. There is blank content area. So now this is skeleton code. You can use this wherever you want. But in this skeleton code, place screen elements here. So this is the overall code for icon tab bar with 3 icon tab filters. While testing the output, first what you do is in your web ID, place your simple form code here, place your list code here, place your table code here. Very simple. Place form code here, list code here, and table code here. And this is the overall icon tab bar. Okay, let me adjust that code now. Let me bring this table code. Table code, I want to put it here in third icon tab filter. I want to place list code in second icon tab filter. List code in second icon tab filter. And I can remove this panel. Now there is a form. So this entire form, there's a form with collection of labels and screen elements. This entire form, I want to place it in first icon tab filter. I can remove the panel. So while adjusting this code, be careful. If begin tag, end tag is not properly closed, then you'll be in trouble. If begin tag, end tag is not available, if it is not closed properly, then you'll be in trouble. So while adjusting this code in icon tab filter, make sure that each begin tag has a separate end tag. And each begin tag has a separate end tag in the same line if it is a simple screen element. For now, I've just readjusted the code. Form here, list here, table here. I've just placed that. Now you can save and run the app. Now let us check how exactly this output looks like. So here you can see there is carousel with a panel, but on below that there is a icon tab bar with 3 icon tab filters. First icon tab filter, content is displaying simple form here. This is complete simple form. And second icon tab filter contains a list code. So the list output is displayed here. Third icon tab filter, there is table code. So you're able to get the table output here. So there's form, list, table. So this is very commonly used icon tab bar in almost in all Fury apps, which is similar to a tab strip with collection of tabs here. So it's working fine. There is no problem. So you can try like this. Now here, we are trying to use standard icon every time here. So how to get this name of the standard icons? How to get this name of the standard icons from the documentation? So let me show that. We are getting this doctor icon, world icon, and you can see process icon. So these three are all standard icons here. I've taken from the help documentation from SAP website. So to get those list of icons, you can go to this documentation. Let me write it here. So to know or get the list of standard icons, how to get the list of standard icons for SAP Fiori apps. So you can open below SAP website. So here you can see SAP ui5.hana.ondemand.com. SAP ui5.hana.ondemand.com. In that, I think you can find something like tools. Go to tool section. In tool section, there is icon explorer here. Icon explorer. If you click on that, you can get list of icons. So go to this tool section and then icon explorer. So when you click icon explorer, you'll get icon explorer tab and you'll get list of icons here. When you click on this, so you'll get icon explorer. Here you can find SAP icons. Okay, go to this link. This is a link. And there you can go to tool section. Then go to icon explorer. And select SAP icons. Then you will find list of standard icons. You can see if I select icon explorer, here you will get SAP icons. If you click SAP icons, then you'll get list of standard icons here. All these are list of standard icons. There are several icons. You can see that with its name. You can see accept is one of the icon. This is a name that you can use it in your coding. Account is one of the icon. Action, add hyphen filter, add hyphen folder. These are different icons. Badge, world, competitor, etc. So you can get list of standard icons from here. Selecting this, it will open this tab. Just select SAP icons, then you'll get list of standard icons. Okay, so how to use custom icon? For example, What's the difference between stand icon and custom icon in terms of syntax? The usage syntax icons, standard icons use icon equal to SAP-icon : / and you can provide standard icon name. The syntax. Wherever there is icon property, only for icon property, these things are applicable. For icon properties, you can use stand icon as SAP-icon : / stand icon name. If you want to use custom icon, use this syntax. Icon equal to just / then custom icon name. That's a basic difference in terms of syntax while using stand icon and custom icon respectively. For custom icon, just use icon equal to double quotes, then / custom icon name. So now here, say suppose I want to use custom icon. Here for table, I want to use custom icon. Instead of process standard icon, I want to use standard icon. So each one is it can be expanded and collapsed here. The content area can be expanded and collapsed. But here, for third icon tab filter, I want to use custom icon. So what you can do is you can import that custom icon. Right click here, import that custom icon into project folder from desktop. For example, I want to use Oasis as a custom icon. So import that. It's already available. So this icon you can refer in your coding. For example, there is third icon tab filter. Instead of using this standard icon, I want to use custom icon. So use / that icon name, oasis.zip file. And save and run this. Now you can see on third icon tab filter, there is a custom icon. Instead of process, now it is taking oasis.zip file. Okay, so that you can use it. But let me go back to the stand icon here. Now it is back to the stand icon. So you can create icon tab bar with n number of icon tab filters. There is no limitation. And each icon tab filter contains a separate content area, and you can place one or many screen elements in each content area. Okay, so what I'll do is in the next session, we'll continue this with table screen element along with formatter functions. And not only that, we'll use different screen elements in different columns. And we'll also apply conditions. We'll make our table output more and more meaningful. So after discussing this, then we'll go for doubts clarification in the next session, not today. Just practice up to here. Then the next session also becomes very easy once if you practice this table. Just practice this table. Just try to analyze the diagrams which are provided. Then in the next session, we can easily add formatter functions. We can apply conditions. We can use different screen elements. Okay, I'll stop here.